Hello Math 2 students. This lesson is 2.11, Comparing and Ordering Rational Numbers. Before we get started with the lesson, I would like for us to go over what a rational number is. A rational number is a number that can be written as a fraction with an integer for its numerator. Remember, the numerator is the number on the top of a fraction, and a non-zero integer for its denominator. The denominator is the bottom number of a fraction. So, what we need to remember about this definition is you cannot have a zero on the bottom of a fraction. It says a non-zero integer. So, a zero cannot be in the denominator spot of the fraction. Remember, an integer is a positive number, a negative number, and zero. So the top number can be positive, negative, or zero, but the bottom number can only be positive or negative. It cannot be zero. That is to have a rational number. Let's look in your books at page 128. We're going to start with number 2. Number 2 says negative 5/8 is what compared to negative 7/8? Well, what we need to remember is that the denominators here are the same. Because the denominators are the same, we can look at the numerators, negative 5 and negative 7, and we can compare them. If we were to put negative 5/8 on a number line, it would be a little less than half. It would be this dot right here. Now, if we put negative 7/8, 7 and 8 are close together, so they are going to be close to negative 1, which that dot there would be negative 7/8. So, negative 5/8 is closer to 0. It's the furthest to the right on the number line, which means that it is greater than negative 7/8. The alligator is going to eat the negative 5/8 because alligators are stingy and they want the bigger part. If we look at number 4, we have 3 4/5 and 3 2/3. That's our problem. What they want us to remember is that the 3 is a whole number and the 4/5 is a part. So the whole numbers, they go to the left of the decimals and the parts go to the right of a decimal. Well, how would we figure out what 4/5 is as a decimal? There are 2 ways, and we're going to look at one of them now. What we can do is we can say, okay, let's put the denominator on the outside of the house and the numerator on the inside of the house. We're going to put 4.00 and take the point up to the rooftop. Now, does 5 go into 4? No, it doesn't. So that's where we have this 0 here. Now, did 5 go into 40? Yes, 5 goes into 40 and it goes 8 times. So 8 times 5 is 40. That cancels out and we don't even need this extra 0. So we know that 4/5 equals 0.8. So then we can look at the second part. The second part over here for the 2/3. We can put a 3 on the outside, a 2 on the inside, 2.00, and take your point up to the rooftop. Then we can say, does 3 go into 2? No, it doesn't. Does 3 go into 20? Yes, it goes 6 times, so we put the 6 here. 3 times 6 is 18. When we subtract, we get a 2 and then we bring down a 0. 3 goes into 20. We're doing the same thing over again, so we can put this little line up here, which means that the 6 is going to repeat. Now, those are the parts, but the wholes are 3, right? So we can put 3.8 and 3.6 repeating. When we compare those two, we can say, okay, the 3's are the same, the decimal's in the same spot, 8 and 6, which is bigger, the 8, so this is greater than. 3.8 is greater than 3.6 repeating.